an agent what to do. So agent need to know its goal, which describe desirable situation. So goal-based agent expand the capabilities of the model-based agent by having those goal information. So they choose an action so that they can achieve the goal. So look at this diagrammatic representation. It will get sense something in the environment that is called a current state, and it will be checking with the current state, with the pause state, what are actions to do. Based on that, it will create one action to do. We're going to check whether the action will be a goal or not. So based on the goal, it will change the environment. That is called goal-based agent. Utility-based agent is, utility is nothing but a measurement of level of happiness. So it will based on the happiness level, happiness state. So it will be checked whether a person will be happy in a particular state or not. Based on the happiness level, it will be behave. So it is actually not based on a goal. It is actually based on the best way to achieve a goal. So that is called the utility-based agent. So look at this diagram. It will get input sense through sensor, current state, and it will be checked with the past history, what an action to be do, having some actions, and it will be checked the utility of an action. That is how happy I will be in particular state. So based on my happiness, the action will be performed and it will change the environment. So that is called utility-based agent. So learning agent, next types of agents is learning agents that it actually learn from the experience and behave by its own, which can learn from its past experience, or it has a certain capabilities that is called learning agent. It is has a 4 components: learning element, critic, performance element, problem generator. Learning element is responsible for making improvements by learning from environment. It will just learn from the environment and making improvements. That responsibility comes to the learning element. Critic means learning element take a feedback from critic which describe how well the agent is doing with respect to a fixed performance standard. A performance element it is responsible for selecting external action. A problem generator it is responsible for suggesting actions that will lead to new and informative experience. So look at this diagram. Sense from the sensor, given input. So from it will give first to critic. Critic give a feedback to the learning element. Learning element get a knowledge from performance element and make a changes. Changes in the sense it will be updating, and it will send the learning goals to the problem generator. Then it will move to the performance element, and then the actuator produce the changes in the environment. So this is called the learning agent or lost agent types. The next topic is problem solving approach to typical AI problem. That is, what are the approaches they will be using to solve some AI problem that is called the problem solving approaches. So they are using rational agents or problem solving agents in AI. They are mostly using a search techniques. So this is one of the problem solving approaches in AI that is called the search techniques. So mostly a rational agent or problem solving agent in AI use those search strategies. It is having an algorithm to solve a specific problem and provide a best result. Okay, so some of the most popularly used problem solving with the help of AI is chess, traveling salesman problem, Tower of Hanoi, water jug problem, and queen problem. So these are using those search strategies. So problem searching means it referred to as finding an information one's need. So searching is the most commonly used techniques of problem solving in AI. It helps us to search for solution of particular problem. A problem is nothing but the issues which come across any system. A solution is needed to be solved that particular problem. So these are the steps for problem solving. So first step is defining the problem and then analyzing the problem, identify a solution, choose the solution, implementation. So defining a problem means first we need to definitions of the problem. First we need to define what the problem, what is its initial state, as well as the final situations. That is called the defining a problem. And then analyzing the problem means we need to analyze the problem and its requirement. That is called analyzing the problem. Identification of solution means based on the analyzed problem, we need to find out the solutions for the problem, generate a reasonable amount of solutions. Choosing a solutions means from those reasonable amount of solution, we need to choose only one best solution. And implementations mean after choosing the best solution, implementation is done. So these are the steps involved in problem solving. So the problem solving performance can be measured by using the evaluator like a completeness, optimality, time complexity, space complexity. Completeness is an algorithm guaranteed to find a solution when there is one. Optimality means the strategy find the optimal solution. Time complexity, how long does it take to find a solution? Space means how much memory is needed to perform the search. So that is called the evaluator in a performance way. Algorithm will be evaluation. So a search algorithm terminologies, it will be having a search tree, action, transition model, path cost, solution. Search is nothing but it is a step-by-step process, a procedure to solve a search problem in a given search space. So it will be having three main factors: search space, start state, goal state. Search space is represent a possible solution which a system may have. Start state means it is beginning the search, state which will agent begin the search. Goal state means which observe the current state and return whether the goal state is achieved or not. So next terminology is search tree. So the tree representation of search problem is called search tree. So root of the search tree is called the root node, which is corresponding to the initial state. Actions will be, it will give the descriptions of all the available actions to the agent. The transition model is a descriptions of what action do can be represented as a transition model. A path cost is, it is a function which is assigning a numeric cost to each path. The solution is, it is an action sequence which leads from the start node to the goal node. And optimal solution is, if the solution has the lowest cost among all the solutions, then it is called an optimal solution. So that is all about the problem search terminologies. So this is one examples for problem solving method using search terminology. So here we will represent so problem will be water jug problem. Two jugs are given. One is 4-gallon jug, another one is 3-gallon. It doesn't have a measuring marker. There will be one pump used to fill the jug with water. So how can we get an exactly 2 gallon of water from the 4-gallon jug? That is the problem. For that problem, we are going to make some solution by using those search terminology. So initial state will be 0, 0. Goal state will be the 4-gallon. First is x, y. First x will be a 4-gallon and y will be a 3-gallon jug. So initially all the jug is empty. So 0, 0. So if you need to make exactly 2 gallon from the 4 column check. So 2 comma n is our goal state. So state space representation is, it is called a x comma y representation. X represent the 4 column check, y represent the 3 column check. So it will be, x will be 0 less than or equal to 0 to 4. 0 and 0 less than or equal to x, less than or equal to 4. And y will be a 0 less than or equal to y, less than or equal to 3. So to solve this problem, we'll be having some assumptions. So the current state of x comma y is, if x is less than 4 means the next state will be a 4 comma y. First we are going to fill a 4 column check. If x comma y is the state, current state, x is less than 3 means then we are going able to fill the 3 column check. So x comma y is the current state, x is greater than 0. That is, something is available in x means x minus d. We are pour some water to the 4 gallon jug, out of the 4 gallon jug. And same thing x comma y, if y having some water greater than 0 means pouring some water out from the 3 gallon jug, x comma y minus d. So the same thing, y is having a greater than 0 value means we are actually empty the 4 gallon jug, 0 comma y. If y is greater than 0 means then we are emptying the 3 gallon jug. So x comma y, if x plus y greater than or equal to 4. So if we are adding 3 gallon jug water and 4 gallon jug water, pouring means both will be greater than or equal to 4. That is, it's 4 gallon means we just make 4 comma y minus 4 minus x. That is, we are getting pouring waters in 3 gallon jug to the 4 gallon jug. And the same thing, x will be having some value. If we are making a y water to the x, then the x will be filled to 3. 3 fully filled means then we are going to do pour some value from x y to x. So that is this state. And if you are adding some value of both x and y that is less than or equal to 4, then also we will make pour all the water from 3 gallon jug to 4 gallon jug.